I'm going to discuss class diagrams. This is our class diagrams part 2. Okay, if you look at my YouTube channel, okay, this is the name of my YouTube channel. There you can find a playlist called UML. Okay, playlist called UML. There, the first part we discuss about class diagrams. Okay, so here I am using a set of slides. The first slide to 17 slide I am discussing it in this particular video in this UML playlist, and in this discussion I am going to start from 18th slide and continue our discussion. And also the owner of this set of slides is Dr. Timothy Lethbridge at the University of Ottawa. And if you go to this particular link, you can find you can download these slides. Okay, so first of all, I thank Dr. Timothy Lethbridge for granting me the permission to use his slides to create YouTube videos. Okay, so in this particular slide, we talk about generalization. In order to understand this video, actually you should have watched class diagram 1 video. Okay, that is available in my YouTube channel. There is a playlist called UML. Okay, in this playlist you can find this particular video, and there I have already discussed slides 1 to 17. Okay, so this is our slide number 18, and we talk about generalization in class diagrams. So specializing a superclass into 2 or more subclasses. Okay, specializing a superclass into 2 or more subclasses. That is actually the meaning of generalization. A generalization set is a labeled group of generalizations with a common superclass. The label, sometimes called the discriminator, describes the criteria used in the specialization. Now, if you look at this one, okay, if you talk about animal class, okay, there you can specialize animal if aquatic animal, okay, aquatic animal, and land animal. Okay, so animals, now aquatic animal is also an animal, land animal is also an animal, but these are special types of animals. Okay, so we can represent it using this kind of notation. Okay, so now In this direction, if you look at in this direction, we call it generalization. Okay, generalization. That means no, not in this direction. In this direction we call generalization. This direction we call specialization. That means aquatic animal and land animal, we can generalize animal as animal. Okay, now animal can be specialized as aquatic animal or land animal. Okay, so actually the same concept, when we think about it bottom up, then we actually generalize the attributes, available attributes and operations in these two classes. We get the common attributes, common attributes and operations to these two classes and put them into a separate class that is called animal. Okay, so that is called generalization, and in this direction we call it specialization. And here actually you can write in this way, you can write a label. Okay, we can label this this generalization or specialization, whatever. Okay, here this term we call, sometimes we call it the discriminator. Okay, and that is one way we can generalize animal. Another way, there are many ways. If you do it in this particular way, carnivore, yes, carnivore and herbivore. This generalization, okay, that depends on the food they eat. Okay, so here the discriminator or label, we can put type of food, type of food. Okay, so here depending on the places they live, whether in water or land, we have specialized animal as aquatic animal and land animal. Here depending on the food, type of food, we have specialized animals as carnivore and herbivore. And here actually one particular thing we can identify these generalizations is, we can see is a relationship, or let's say in English is or is an. Okay, is or is an. In this situation, aquatic animal is an animal. Okay, land animal is an animal. Okay, so actually in this direction we have done specialization, we have specialized. And here carnivore is an animal, herbivore is an animal. Therefore in this direction we have specialized animal class. Okay, and if you know, actually this is called inheritance as well. If you have watched my previous videos, now you know what is inheritance. And what happens here, what happens, actually aquatic animal class inherits all the attributes and operations available in animal class, and also land animal class inherits all the attributes and methods available in animal class. Here also we have inheritance, then carnivore class inherits all the attributes and operations available in animal class. Herbivore class inherits all the operations and attributes available in animal class. Okay, that is generalization. And now let's move to the next slide. Now when we talk about generalizations, actually you have to use your own intelligence. Okay, there are no rules, no strict rules in UML. You have to think and do the things appropriately. Okay, so that is actually the beauty of UML. You are free to think. Okay, and now if you look at this one, avoid unnecessary generalizations. That means if you look at this, diagram, recording a particular recording, here it has been divided into video recording and audio recording. Then we have is a relationship, no? Is a relationship is there. Video recording is a recording, audio recording is a recording. Now here also music video is a video recording, jazz recording is an audio recording, is or is an. Okay, classical recording is an audio recording, blues recording is an audio recording, rock recording is an audio recording. Okay, likewise logically there is no problem with this generalization. Okay, but you have to, when you model, you have to always think about better models. Okay, so let's see. Now this is one way of doing this. Now let's see another way of doing this. Okay, so this is another way. Now we have the recording class. Okay, recording class is there. We have a title for a recording and an artist. Okay, okay, then here we, instead of having it in this way, okay, instead of having it in this way, we create a class called recording category. Okay, in that way recording category, here we put an attribute called label. Okay, then here now we have an association. Instead of generalization, we use an association here. 1, here 0 or more. Okay, that means for a one particular recording, their recording category, there can be 0 or more recordings. Okay, for one particular recording category, there can have 0 or more recordings, and if you consider one particular recording, it is associated to exactly one recording category. Okay, so and here we can have reflexive association. an association to the same class, and one here multiplicity is 0 or more, and here we put subcategory. That means what now can we interpret the meaning of this one? If you consider particular recording category, there are 0 or more subcategories. Okay, if you consider one particular recording category object, okay, so it has 0 or more subcategory objects. Okay, and if you consider one particular subcategory, it is associated to exactly one recording category. Okay, so in this way also we can represent. And now let's now this is our class diagram. No, this is our class diagram. Now instead of modeling it using generalizations, we have done it in this way. Then I claim that this way is better than modeling it in the previous slide. You have seen it modeling using generalizations. So I claim that this is better. So you have to think how can this be better than the previous modeling. Okay, in that way you have to use your common sense and understand what is the best way. Okay, so then let's see now. This is the class diagram, and this one is called the instance diagram or the object diagram. Here we have shown classes, and in this diagram we show now this is an association. These are associations. Once you show it in the instance diagram or the object diagram, you see the associations as links. Okay, now let's see that one, the corresponding object diagram. Okay, so here this is an object from recording category class. Okay, this is an object from recording category class. Recording category. Okay, so an object we represent in this way, no? Underline, we can underline, because the meaning of this one is this is an object from recording category class. Okay, this is an object from recording category class. Now here we have a label. Put the label as audio. Now this is an audio recording. Okay, audio recording. Now this is an audio recording. Okay, so here now if you look at this reflexive association, now we have 1, 2, 3, 4 objects. Okay, here now recording category the label of this one is jazz recording. And now here you can, this association here, it becomes a link. So this object and this object is linked, and here role is subcategory. Okay, so that is again now there is another recording category. Label is classical. Here we have this one here, sub category. Okay, so here another one, you have recording category, label blues. Here the label is blues. Okay, now these two are linked, subcategory. Role, we put the role here. The meaning is, if you consider these two objects, for this object this is a subcategory. Okay, now let's another blues and another subcategory is there. I draw it here. Recording category, and here the label rock. Okay, then now here in here we have this one, and here subcategory. That means now there are 1 2 3 4, okay, 4 objects. Now again let's go back to the previous slide. There we have modeled it in this way: audio recording and jazz recording is an audio recording, classical recording is an audio recording, blues recording is an audio recording, rock recording is an audio recording. Okay, in that way here we have modeled it as, now we have 1 2 3 4 5 objects, then they are associated like this. For one particular category, these are subcategories. Okay, so this is another way of modeling. Then I feel that this way is better. Okay, so you have to think and understand why this way is better. If you do not understand it at this moment, later you will understand when it comes to implementations. Okay, you will understand. Then here, if you consider one particular recording category, for one particular recording category there can have 0 or more recordings. Okay, now in the classical yes, category, we have recording. Okay, title Ninth Symphony, symphony. Artist Beethoven. Okay, so uh, this one, these two, and the role is, this is the category. Okay, that is the role. And now if you look at rock, here we have a recording. Okay, title, let it be. Let it be. Then artist, the Beatles. Okay, in this way, now these two are associate, have a link, and here the role is category. Okay, in this way we can represent, this is called an object diagram, or we call this instance, diagram of our this class diagram. Okay, and now here recording category, we can put, now for the recording category there are two objects, this one label audio, this one label is video. Okay, so here we have another recording category, label video, and recording category, this one label is music video, and now here we have the link, and this is subcategory. Okay, so subcategory, okay, it's not that much legible, anyway, subcategory. Now recording category, two objects. Okay, we instead of considering it as an inheritance, we have considered it as two categories, this one and this one, audio and video. Okay, then for audio we have considered it as subcategories. Okay, for video also, instead of having it as an inheritance, we have considered it as a subcategory. Okay, in this way we can avoid unnecessary generalizations. We use generalizations where necessary, and if you compare with the implementation of a generalization and implementation of an association, then you will properly understand in future, you will properly understand why we call this method is better than the previous. Okay, so anyway, what I wanted to tell you is we have to always avoid unnecessary generalizations. Okay, and then let's go to the next slide. Okay. This is an example for handling multiple discriminators. Now, in this way, creating higher level generalization, you can do it in this way. Aquatic carnivore, aquatic herbivore, we can generalize these two classes as aquatic animal and discriminator is type of food. Land carnivore and land herbivore we can generalize and the discriminator is type of food. Now generalized class is land animal. These two classes we can generalize depending on the habitat. Okay, this is just an animal. Okay, in this way we can handle multiple discriminators. Now if you look at you know, if we were talking about Java programming language. Java programming language does not support multiple inheritance. Multiple inheritance is not supported by Java. Okay, multiple inheritance means if we have one particular class in Java, one particular class can have at most one superclass. If you consider one particular class in Java, either it has exactly one superclass or it has no superclasses. Okay, so multiple inheritance means if you have more than one superclass for a given class, in that situation we call it multiple inheritance, and this is not available in Java. Okay, so here we have not used multiple inheritance, and in Java we can implement this kind of a class diagram. But if you look at this one, here the same situation has been modeled using multiple inheritance, and animal can be specialized as aquatic animal, land animal. Here in this part no problem, no multiple inheritance, and depending on type of food, here we have specialized as carnivore and herbivore. And here aquatic carnivore means both we inherit from carnivore and aquatic animal, then it becomes an aquatic carnivore. If we inherit from aquatic animal and herbivore, aquatic herbivore. If we inherit from land animal and carnivore, land carnivore. If we inherit from land animal and herbivore, land herbivore. Okay, so this is another way. Another way. So, but in Java, this one is not possible. Since we have in here, we have inherited from more than one class. There are more than one superclass. Therefore, this is not possible in Java. Therefore, you have to be careful. And here in this slide, using the player role pattern in chapter 6. Actually, if you go to this particular link, then you can find a book written by Dr. Timothy Lethbridge and another author. So they are referring the chapter 6, okay, of that book, and also these slides are based on chapter 5 of that book written by these two authors. If you are interested and if you want to learn further, you can read the book. Okay, and now Now avoid having instances change class. Okay, so there is a good practice, that is an instance should never need to change class. That means if you look at something like this, if you have the student class, okay, we can specialize it as full-time student. Okay, now full-time student and part-time student. Okay, now we this one depending on attendance. Discriminator is attendance. Okay, sorry. Attendance, and this is the discriminator. Now you know full-time student is a student, part-time student is a student, and the problem with this kind of modeling is, let's say in in this situation, let's say we create an object from this particular class. Okay, then in Java, full-time student, let's say X, new full-time student. Okay, now we have created an object, okay, referred by, now we have created an object referred by X variable. Now let's say in our university we allow students to swap between full-time and part-time, time to time. That flexibility is there. Sometimes a student registers for a particular course as a full-time student. After 6 months or 7 months, if he or she wishes, they are allowed to change it to part-time. Okay, again to full-time and something like that. Okay, so if they have the flexibility, in that situation this modeling fails. Okay, now let's say now this student is going to again to become a part-time student, then you cannot, now this object is from full-time student class, now you cannot change the class. Okay, so therefore in modeling you have to be careful with the existing scenario. Okay, this one may be suitable for a situation where students are not allowed to swap between full-time and part-time. Then this is okay, then students never have to we do not have to change the class. But if students are allowed to change full-time and part-time, then this modeling fails. Okay, in that way you have to think about suitable situations. Okay, now we talk about object diagrams. I have already shown you object diagrams. Okay, now we officially discuss object diagrams. Now let's say okay, now let's talk about object diagrams. And now let's consider this particular class diagram where we have two classes, employee class and company class. Now these two are associated. Now this is an association, no? This is an association. Now we have Yes, not only this. Okay, so I will redraw. Now, uh, employee class is here. Okay, employee class is here. Okay, then company class is here. Then let's say we have a class called board. Okay, director board or something like that. So these two are associated and these two are associated. So this is an association. So now if you look at objects, now in this part, let's say we have a particular company called double O Corp. We have a company, so we write it here, the name of the object and the class, okay, an object from this class, and we underline it. Okay, that is how we represent objects. Okay, so now in this particular company there are three employees, Pat, Wine and Ali. Okay, Pat, an object from employee class. Here we put, this is called a link. Okay, this is an association. Now in the object diagram we call this a link. Okay, then wine employee, okay, then Ali employee. Okay, in this way. Now here this is an association. Let's say double O Corps, double O Corps board, and here let's say in the slide this is missing. If our class is board, here we can mention it, and in this way this is the object, and now we can link them. Okay, actually this is part of our object diagram depending on this particular class diagram, and we have a company, particular company. In this company we have three employees, and also we have one particular board. Okay, so again let's say we have another company, UML Inc. Company class, and now here this is the object. Okay, UML Inc.'s board, Inc.'s board. So we inherit from board, and these two we have a link here, and there are, in this particular company there are two employees, Kala employee, Terry employee okay. Now this is the object diagram of this particular class diagram. Okay, so that is how we draw object diagrams. What you have to understand is an association now can become several links. Okay. Now let's move to the next slide. So now associations versus generalizations in object diagrams. Actually, if you look at this, associations describe the relationships that will exist between instances at runtime. Okay, once then objects are created at runtime, and now the okay, so associations describe the relationships at runtime. When you show an instance diagram generated from a class diagram, there will be an instance of both classes joined by an association. Okay. Okay, so if you look at an association in a class diagram, if this is an association, when you look at the corresponding object diagram, you can see links instead of this particular association. Okay, and when it comes to generalizations, generalization describe relationships between classes in class diagrams. They do not appear in instance diagrams. Okay, now if you have generalizations, for an example, previous situation we had animal class. Okay, now this generalization that actually do not appear in object diagrams. Okay, when we model with objects, this does not convert to anything. Okay, but associations converts to links. Okay, an instance of any class should also be considered to be an instance of each of that classes superclasses. Okay. Okay, that is another thing. So next move to the next slide. We talk about more advanced features in a class diagram. So here aggregations are special associations that represent part-whole relationships. The whole side is often called an assembly or the aggregate. The symbol is a shorthand notation association named is part of. For an example, if we have a class called vehicle, okay, and now another class vehicle part, okay, vehicle and vehicle part. Now vehicle and vehicle part. We have two classes. If you consider a particular vehicle, okay, vehicle, and this is the vehicle, and what you can consider several vehicles, okay, one vehicle, then another vehicle, okay. So now vehicle part, the vehicles are the objects of this particular class. Vehicle part class, what are the objects? Steering wheel, wheel, okay, this particular wheel is an object from vehicle part class. This particular wheel is an object. This particular wheel is an object from vehicle part class. Then steering wheel of this vehicle is an object from vehicle part class. Steering wheel of this vehicle is an object of vehicle part class, okay. So in this situation we can represent it as an association, and label is part of vehicle is part of, we may put the direction, is vehicle is part of vehicle part. We specify the direction here, otherwise someone may read it in the other way around. No, vehicle part is part of vehicle, no. Therefore using this kind of an small arrow like symbol, we can specify the direction. And now is part of association occurs frequently. Is part of association occurs frequently in class diagrams. Therefore the people who have who work standardized UML, they have decided to introduce a separate notation for this is part of this kind of an association. So that is called an aggregation, okay. In this way we can represent it, vehicle, without labeling it in this way, vehicle and vehicle part, okay. Here we put this is the whole, this is the part, okay. So the whole, this is the whole and this is its part, okay. So to the whole we put this kind of a symbol, and now we call assembly or aggregate. These two words are also used to call vehicle, and now this is its part, and now if you consider this is an, in this symbol we represent an association, using this symbol we represent an aggregation. Actually aggregation is also a special type of an association where we have this whole part whole relationship, okay. So that is also an association, okay. Then if you another example we can see, if you look at the country and region. Country it has regions as parts, 1 2 3 4, likewise a country is composed of regions. Therefore here also we can use this aggregation symbol, and if we need we can put multiplicity. One vehicle can have 0 or more vehicle parts, and one vehicle part is related to exactly one vehicle. Here also a country can have 0 or more regions, and one region is related to one particular country. Okay, in that way if we want we can specify multiplicities. Okay, now let's move to the next slide. Then when to use an aggregation, that is the question, no? As a general rule you can mark an association as an aggregation if the following are true. You can state that the parts are part of the aggregate. Okay, parts are part of. Now region means actually if we create a country object, now region objects are its parts. Okay, so E are part of or aggregate is composed of. Okay, here are parts. Okay, regions are parts of the country. Okay, and here vehicle is composed of parts. Okay, something like that. Use your common sense and try to understand. When something owns or controls the aggregate, then they also own or control the parts. Okay, when something owns or control the aggregate, then definitely its parts are also getting controlled. When we go to implementation level, you can properly understand this. At this moment you just keep this one in memory. Aggregation is also an association, is part of type associations. We have a special symbol, this one, for them we use that. Okay, now another type that is called composition. Okay, that is called a composition. A composition is a strong kind of aggregation. If the aggregate is destroyed, then the parts are destroyed as well. That means you have a building. Okay, if you have building class, now you have buildings. Okay, so let's say this is a building, 3-story building. Now they have rooms, no? Okay, now building rooms are the part of the building. Therefore here we can put definitely an aggregation, and let's say we put multiplicity. That means if you, in our system we store buildings. Okay, we store buildings, and each building can have 0 or more rooms. Okay, if you consider one particular room, it is situated in one particular building. One room can not be situated in several buildings, no. Therefore here it is one. And now the difference between, now we talked about aggregation. We have talked about aggregation, and if you put it as an aggregation, then that this means if from our information system, if we let's say now building 1, building 2, here we have 3 rooms, 2 rooms. This building has 3 rooms, this building has 2 rooms. Okay, so this is the object diagram, not exactly, okay, object diagram like thing. Okay, not a complete object diagram. Now if we use it An aggregation, that means if you uh, delete building object uh, from our information system, then rooms are not deleted. We are not going to delete these room objects from our system. Okay, if you use an aggregation, it is something like that. But if you use now composition, means we fill this one. Now this is a composition. In a composition, if we delete this, then we are going to delete the corresponding rooms as well. Okay, that is the difference between aggregation and composition. I will re-explain it using this one. If we use aggregation, okay, between these two, if we have aggregation, let's say if we have aggregation, then if we delete this particular object from our information system, then we are not going to delete these two in an aggregation. Okay, but in an composition, if we delete this one, then we are going to delete associated parts as well. Okay, that is the difference between aggregation and composition. Okay, so now two alternatives for addresses. Now this one, in this way we can use composition. Now if you have an employee, so this is one particular way to store address. Now as an attribute, let's say in this way, employee class, we have address attribute, its data type. In Java we might write the address in a string. Okay, this is one particular way, but we think about a better way for this one. Okay, so in this way we can model this. Now employee, actually address is a part of the employee. Okay, because now if you model this, let's say if we model this using a composition like this, okay, we model it as a composition, then address street municipality, region, country, postal code, region, country, postal code. Okay, so in this way now we can model it using a composition. Now the idea here is, if you delete a particular employee object, then corresponding address should also be deleted from the system. Okay, let's say now there are employees E1, E2, E3, E4, address 1, address 2, address 3, address 4. We have a one-to-one relationship. Let's say it is something like this. Now since we have used a composition, if you delete this particular employee object, then we have to delete the address object as well. If you delete this one, we have to delete the address as well, because here we have used a composition. Okay. Now I hope you could understand the difference between aggregation and composition. Aggregation and composition. So now I summarize. This is an association. We represent it using a straight line segment. Actually, an association means combination of these two. Okay, these two unidirectional associations. Actually, we have to write it something like this, no? So instead of writing it like this, we just put a straight line segment. And now if you consider associations, there is a special type of association called now this is just an association. If the association has the relationship, the label is part of like label, then we can use this special symbol. This is called aggregation. And in aggregation, if we delete an object from whole class, then corresponding object, the associated object of the part class, we do not have to delete. Okay, but composition means this is called, actually we say composition is a strong kind of aggregation. That means in this situation, if we delete an object from whole class, then the associated object of the part class should also be deleted from our system. Okay, so now you know, in a class diagram there are actually two relationships, associations and generalizations. Okay, these are the two types of relationships. Now in a class diagram means actually we represent the classes, then their attributes, their operations and relationships. These two are the relationships. Okay, now let's move to the next slide. So here we have aggregation hierarchy. If you consider a vehicle, now vehicle is composed of chassis, body panel, door. Okay, if you consider a particular vehicle, okay, then we can use aggregation, because now vehicle is composed of chassis, a chassis, and here one chassis is in one vehicle. Okay, and here one chassis is there. For one vehicle, one chassis is there. Then body panel for one particular vehicle there are 0 or more body panels. If you consider doors, for one particular vehicle there are 0 or more doors. Okay, and if you consider the chassis, it also is composed of, now Here we put 1 because frame is associated with one chassis, and one chassis has one frame, one engine, okay, then one transmission system, okay, then 0 or more wheels, okay. So in that way we can represent aggregation hierarchies as well. Now let's move to the next slide. There we have something called propagation. A mechanism where an operation in an aggregate is implemented by having the aggregate perform that operation on its parts. At the same time, properties of parts are often propagated back to the aggregate. Propagation is to aggregation as inheritance to generalization. Okay. Now there is certain thing is called propagation. Okay. We have polygon class, then line segment class. Okay. Here now let's say we have the composition 1, 0 or more. That means if you consider a polygon, this is a polygon, no? Polygon. This is composed of line segments. Okay, therefore we use, and also we use this composition. And also if you delete a particular polygon object from our system, it's all the line segments of that polygon also should be erased from our system. Okay, that is the meaning when we use a composition. And now inheritance is an implicit mechanism. Okay, inheritance means actually if we put inheritance, that is an implicit mechanism because all the attributes and operations in the superclass will be inherited to the child class. Okay, that is an implicit mechanism. But in propagation it is a mechanism where an operation is an aggregate is implemented by having the aggregate perform that operation on its parts. At the same time, properties of the parts are often propagated back to the aggregate. Okay, it is something like that. Propagation is not happening in an implicit way like in generalization. If it is necessary in that situation, we have to program it. Okay, we have to program when it is required. Okay, and yes, now that is that's something about propagation. And then let's move to the next slide. Yes, now this is our class diagrams part 2. This video is our class diagrams part 2. Okay, and then at the very beginning I told you that you have to watch class diagrams part 1. before you watch this particular video. Here I discussed slide numbers 1 to 17, and in this particular video I discussed slides from 18 to 30. Okay, then in our next video, class diagrams part 3, I will discuss from the slide 3 onwards. Okay, if you could understand what I have discussed, okay, so I have a small request. You can subscribe my YouTube channel, and also if you have any questions, okay, if you have any questions, you can ask them in the comment section, then I will answer them. Okay, that's what I wanted to tell you. And finally, I thank Dr. Timothy Lethbridge at the University of Ottawa for giving me the permission, granting me the permission to use these slides. Okay, and for you also I thank for watching the video.